All right. So finally, I just wanted to do a couple exercises from 1.3 with you. So we're just looking at the first set of exercises from section 1.3, where we're given a whole bunch of different arguments, and we're asked to determine if they're deductive or inductive, and then what type of deductive or inductive argument they are. And I want to emphasize that you'll be asked to do exactly this kind of thing on the exam on this material. So this is a very good section to practice with. And we'll just do a couple of the non-starred problems, and then you can do the rest of those, again, through Applia or by certainly using the answer key in the back of the text for the starred problems. So be sure you're working on that. So number 2 here, then, says that the plaque on the Leaning Tower of Pisa says that Galileo performed experiments there with falling objects. It must be the case that Galileo did indeed perform those experiments there. So what you always want to pay attention to when you're analyzing these arguments in terms of what type they are is especially pay attention to the conclusion. The conclusion of this one, right, comes after the phrase, it must be the case that. And so the conclusion is Galileo did indeed perform those experiments there. And so what we need to ask ourselves at this point is, okay, why do they believe that Galileo performed some experiments at the Leaning Tower of Pisa? Well, the premises tell us that they believe that because a plaque tells them it's true. Well, a plaque, of course, is a type of sign. And so this is an argument from signs. And you could do it either way, argument from signs, inductive. I mean, that's usually how this works out. You figure out the type it is, and then that tells you if it's deductive or inductive, or you could list inductive or deductive first. But I'll just put it there. So it's an argument from signs. Any argument from signs will be an inductive argument. All right, so let's do a couple more. Number 3 here says, the rainfall in Seattle, so we can relate to this, right? The rainfall in Seattle has been more than 15 inches every year for the past 30 years. Therefore, the rainfall next year will probably be more than 15 inches. Now again, what we want to pay attention to first is what the conclusion is. And the conclusion here is that the rainfall next year in Seattle will probably be more than 15 inches. So the conclusion is about the future. It's about next year. Well, anytime you're talking about the future is not guaranteed, but it is likely, certainly in terms of this kind of example. And so we're talking about certainly an inductive argument. If we're talking about the future, though, we're talking about a prediction. And again, as I've said, that would be an inductive argument. All right, let's do 2 more here. Number 5 says, Amoco, Exxon, so I'm skipping 4 because it's a starred problem. Amoco, Exxon, and Texaco are all listed on the New York Stock Exchange. It must be the case that all major American oil companies are listed on the New York Stock Exchange. So, once again, we're paying attention to the conclusion. It must be the case, right? Tells us where the conclusion is. What? What must be the case? That all, so we have the conclusion starting with the word all. So perhaps we're thinking, oh, categorical syllogism, right? One of the claims starts with all. But when we look at the premise here, the premise does not start with all, no, or some. And so this is not a categorical syllogism. But we are concluding about all of something, right? All of the major American oil companies. And how does this argument get to that conclusion about all the major American oil companies? It does that by citing 3 specific examples of major American oil companies, right? So you're starting with a small sample of major American oil companies and then concluding about all of them. And anytime you're doing that, you're making an inductive generalization, clearly. Okay? When you start off with a small sample, then conclude about all, you're making an inductive generalization. Now, in case you had any temptation here or inclination to think that perhaps this was an argument from analogy, well, it's not as if the argument is comparing one American oil company to another American oil company. It doesn't conclude about a specific American oil company or even a specific couple of American oil companies. Since the conclusion is about all major American oil companies, that's what really tips the scales to be an inductive generalization, which, of course, is inductive as well, and you could list that, but it's not really necessary here. All right, finally, number 6. The longer a pendulum is, the longer it takes to swing. Therefore, when the pendulum of a clock is lengthened, the clock slows down. So the conclusion here is about when the pendulum of a clock is lengthened, the clock slows down. And why do they believe that? Well, they believe that because apparently the longer a pendulum is, the longer it takes to swing. So we're talking about pendulums here, which of course is in the realm of physics, right? And it seems like they're concluding that they're concluding that when that pendulum is lengthened, not that this really helps anything, but when the pendulum is lengthened, it takes longer to swing, and they're basing that conclusion on a principle that the longer it is, the longer it takes to swing. So they're taking this abstract principle about pendulums and then applying it to a clock. So it's in the realm of physics. It's actually a scientific argument. But of course, as we know, this is the one type of argument that can go either deductive or inductive, right? And so we have to decide, is it deductive or inductive? And what tips the scale one way or the other will be, well, this stuff about pendulums here, how determined is that? In other words, is that something we've known about for a long time, or is this a newly discovered science or physics in this case, right? And I hope you recognize, of course, that clocks and pendulums have been around for a long time. We've known about these things for a long time. And so the conclusion here about when you lengthen the pendulum of a clock, it will take longer to swing, is something that we can go ahead and consider a deductive argument. And so we would write deductive here simply because the science in this case is very well established, again, dealing with pendulums. It's not dealing with newly discovered substances or some weird thing that happens in a particle collider or something like this. Pendulums are well established. And so when you identify something as a scientific argument, be sure to think carefully about whether or not it would be deductive or inductive.